Good morning, everyone. Now, the next topic that is under number system, and the next topic is like how to convert any decimal number system into any other base. And in case of that, we are having three kind of other base, like binary we are having, then octal number system we are having, and hexadecimal number system we are having. So, in today's session, I'll tell you that how to convert any decimal number system into binary number system. So this is the topic for today. So let us discuss like how to convert any decimal number system into binary number system. So before going on to that subtopic, you just have a look like how many total conversion we are having in number system, so that you don't get confused. Like one by one you can check that. First of all, we are having like decimal to binary conversion, then decimal to octal conversion, decimal to hexadecimal conversion. Okay, then after that we are having like binary to decimal conversion, means vice versa, like binary to decimal, octal to decimal, then hexadecimal to decimal. Okay, these two are the like conversion in case of a vice versa process. Then after that we are having like binary to octal conversion, binary to decimal conversion, binary to hexadecimal conversion. Then same like that we are having like octal to binary, octal to decimal, and octal to hexadecimal conversion. Then what is left here, we have not taken the hexadecimal conversion. So just you just take the next conversion, that is hexadecimal. So hexadecimal to binary conversion, hexadecimal to octal conversion, and hexadecimal to decimal conversion. So maximum or I think almost all types of conversions we have taken. Now one by one we will discuss that how to convert these number system into another or into any other base number system. So today I'll take only one, and then after that if you have a strong concept of it, then after that I'll take two or more types of conversions in the next lecture. Okay, so carefully you just check this video, and you just take one rough notebook also, so that you can practically you can convert this practically you can solve this conversion. Okay, so you just have a look like decimal to binary conversion. So first of all, what do you mean by decimal number system? As decimal number system means in case of decimal number system you are having the base, that is 10. Okay, that means as I have told you that always you will start a digit from 0. That means if you are starting from 0, then this is one digit, then after that it will goes up to 9. That means if the base is 10, then it will start from 0 and it will goes up to 10 minus 1, that is 9. Okay, and in case of decimal number system, every number represents like this, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Means in case of a decimal number system, if you are taking any of the example of decimal number system, then you can have only these number of digits. Okay, so the base of decimal number system is 10 because it has only 10 digits. So in case of binary number system, the base is 2 and only 2 digits you can have in case of binary number system, that is 0 and 1. Means every number or every value of binary number system will represent with this 0 and 1. Like the example of this binary number system can be like 11011, and it can be 10101, because the base of binary number system is 2, and that is why it is having only 2 digits, that is 0 and 1 only. Okay, now just have a look to this example. First of all, I'm telling you like what are the number of steps which we have to follow in case of decimal to binary conversion. Okay, so the first step in case of this conversion is, first of all, you just write the decimal number which you want to convert into any other conversion. Okay, first of all, you just write it. Then after that, you just divide that number. You just divide that decimal number by the base of the target base system. Means if you want to divide this decimal number system into binary, that means you have to divide this decimal number by 2. Okay, and if you want to convert this decimal number system into octal, then you will divide the decimal number system by 8. If you want to convert this decimal number system into hexadecimal, then the base in case of hexadecimal is 16. That means you will divide the decimal number system by 16. Okay, this point is clear? Hope this is clear. So this is the first step. Because we are converting the decimal number system into binary, so we will divide our decimal number by 2. This is the first step. Then what will be the next step? Just have a look. Like you have to write the remainder. You have to write the remainder from step number 1 as a least significant bit. Okay, and you have to move up to the most significant bit. Like how? Just have a look. Like this is one decimal number system, that is 1 2 3 4 5, and you have to convert it into binary. Okay, this is why you have written 10 here, because you are having one decimal number system and you want to convert it into base 2. That means here is the question mark, and you have to find out the result of this. Means you have to convert this decimal number system into binary. Okay, so you just have one rough notebook. Then after that, you just write this digit, this decimal digit. Then after that, because you want to convert into binary, so that is why you have to take 2. You have to divide this number by 2. Okay, so one by one you just divide this given decimal number. So you are dividing this by 2. So 2 6 are 12, then 2 1s are 2, then it will be 14, then 2 7s are 14, then 2 2s are 4. That means there is one remainder. So you just write it in front of this decimal number system. So this is your step number 1, and this is your first least significant bit. So you just write the remainder here, whatever you are having. Like if you are having 0, then you just write 0 here. If you are having 1, then you just write 1. Okay, so, and you don't forget to write LSB and MSB, because whenever we will write the result or the answer, then this will be noted, like from where, because in case of result, we just write the answer from this most significant bit. That is why. So you just write on the top, that is LSB. Then in the bottom side, you just write MSB. Now the next step, then divide this number by 2. So 2 3s are 6, then 0, then 2 8s are 16. Okay, because if you want to divide this one, then it will not be divided. But if you will take it, if you want to divide the 6 17, then 2 8s are 16, then 1 will come here. That means 2 6 are 12. That means remainder part is 0. So you just write in front of this that the remainder part is 0. Whenever we are dividing this number by 2, then we are getting the remainder, that is 0. Okay, done. Then the next step, divide this number by 2. Okay, then 2 1s are 2, then 1 is remaining here, that means 10, 2 5s are 10, 2 4s are 8, 2 3s are 6. That means the remainder part is 0 again. Then divide by 2, 2 7s are 14, 2 7s are 14, 2 1s are 2. That means 1 is remainder here, and 1 is remaining. So that is why you are writing in front of this that 1 is the remainder in case whenever we are dividing this number by 2. Okay, then just like that, you just follow this step 2 3s are 6, 2 8s are 16, then 2 5s are 10. That means 1 is again remainder, then write it here. 2 1s are 2, 2 9s are 18, 2 2s are 4. That means again 1 is remaining here. So just write it in front of this number, because in whenever you are dividing this number, then you are getting 1 as a remainder. So that is why you are writing in front of this. Then 2 9s are 18, then 2 6s are 12. That means nothing is remaining here. That means remainder part is 0. 2 4s are 8, 2 8s are 16, again 0. 2 2s are 4, 2 4s are 8, again 0. 2 1s are 2 and 2 2s are 4, again this part will be 0. 2 6s are 12, then 0. 2 6 are 12, as I have told you. Then 2 3s are 6, that means again it is 0. Then whenever you will divide this 3, 2 1s are 2, means 1 as remainder, so you will write it here. Then in the last step 1 is remaining. So what you do, you just write it in the most significant bit. Okay, so this is your most significant bit, and then after that this is your least significant bit. So whenever you will write your answer, then you will start from MSB. You will start from most significant bit. Okay, so when you are writing your answer or result from this digit, so write it like 1, then 1, then how many zeros are here? 1 2 3 4 5 6. So you have put 6 zeros here. 1 2 3 4 5 6. Then 1 1 1. So you just write it 1 1 1 1 1. Then 0 0 1. So write it 0 0 1. So this is your final result. Means this is the binary conversion of this decimal number. Okay, so just solve it by your own in your rough notebook. Then after that you just note it down in your subject notebook. Okay, then just take another example, like if you want to convert the decimal number, that is 13. This is one decimal number system, and you want to convert it into binary number system. Then what you will do, again, because you want to divide this decimal number system into binary, so that is why you will divide this 13 by 2. So whenever you are dividing this 13 by 2, then whatever you are getting, 2 6 are 12, that means 1 is remainder here, so you just write it here. And this is your least significant bit, as I have told you in the earlier example also. Then you will divide this 6 by 2, then you will get 3, that means remainder part is 0. Then this 3 will be divided by 2, then that means you are getting 1. So 1 is remainder here, so you will write in front of this. Then 1 is the remainder in the previous step. So 1 divided by 2, that means whatever you are getting, what you are getting, that is 0. So that means you can write it 1 here. Okay, that means or you can understand like this, because 1 cannot be divided by 2, that is why you can directly write to 1 here, as we have done in the previous example, like this. 1 cannot be divided by 2, so that is why you have written this one in the MSB. So just like that you can do in the case of this also, like 1 it cannot be divided, or so you can directly write this one into the MSB. So whenever you will write your answer, then you will start from this MSB. You will start writing from this most significant bit. So so the conversion, the binary conversion of this 13 will be 1 1, then 0, and then 1. Okay, and base 2. Hope this is clear. So just solve these solve examples in your notebook first. Then after that I am having some practice questions. Whenever these two examples will be clear to you, then only you just solve these practice questions. That is 262, this is one decimal number system, you have to convert it into binary. Then the next one is 98, then 550, 195, 156, 285. Okay, so just try to solve these binary these decimal number system into binary number system. Okay, and if you are having any doubt, then we will discuss it in the interactive session. So tomorrow I'll take you interactive session so that problems can be resolved if you are having. Okay, so till then you just practice of these questions. So thank you everyone, thank you so much.